Kind of ran up against the 10-minute limit there for YouTube. So here's part 2, and I'll go ahead and show you the p-value method. Basically, steps 1, 2, 3, and 4 are all the same, except for step 4 we're going to do a little bit different things. So here's what I'm going to do. I'm going to go ahead and just copy this, and I'm going to create a new sheet here. So here's my here are my hypotheses, and then we also found out that x bar is supposed to be normal with a mean of 2.2 and a standard deviation of 0.02828, right? Okay, so now we're going to go ahead and draw this distribution again, and this time we're only going to locate where our sample mean is. Here's our sample mean, 1.6. Remember the p-value method, and that's what this is again, p-value method. The p-value method, basically you figure out what the p-value is. The p-value is the probability of getting a sample result as extreme as your sample data. The probability of getting a sample result here as extreme, so here or there, that way to the left, as your sample data. Here's our sample data. What's the probability of getting a result as extreme as this? Okay, now in a two-tailed test we've got a little bit of a complication, because if we're not interested in which side we are on as far as being extreme, we could be just as extreme to the right. Okay, so the probability really is going to be that area there plus the same area on the right side, because this is also just as extreme on the other side. And since we don't have an inequality here, we just have a not equals, we're really not concerned which side we're on. Either one would be fine. So what we really need to do is find this probability, and we can just multiply it by 2. In a one-tailed test like the one we did this morning in class, we wouldn't be multiplying it by 2. We'd just be looking at one tail of it. Okay, so we can do this with the calculator by looking at normal CDF, negative big number, 1.6, then the mean, then the standard deviation. And if I put this in the calculator, I'm probably going to get a really, really, really low number. So let's see what I get. Put it in the calculator, 1.6, 2.2, 0.02828, and yeah, my calculator basically comes up with a 0. Okay, that's because my standard deviation is too small. Okay, so basically this probability is equal to 0. Normally I would take it, multiply it by 2, that would be my p-value. In the end, you compare the p-value. So to keep it consistent with what we just did, this is step 4. Step 5 then is our conclusion. Step 4, finding the p-value. Let me write that down here, p-value. Okay, and then we say, since the p-value is less than alpha at 0.05, there is enough evidence to reject HO. So we'll say that the true mean of first-year college students is not 2.20. There you go. Okay, cool. Let me show you one thing here. Let's suppose our sample result was something a little bit closer to 2.2. Okay, and I'll show you how that works. Let's suppose instead, okay, let me put the hypotheses up here again. Let's suppose that instead of 1.6, our sample mean was 2.10. Okay, So we'll do that instead. Distribution is going to look basically the same, still have a mean at 2.20, but now we're going to figure out our p-value based on more extreme than 2.1. So if I do that, normal CDF, negative big number, 2.1, 2.2, 0.02828. Let's see what we get with this. If I put that in the calculator, I get 2.1. I still get 0. Didn't go far enough. We get to play with the numbers. Let's suppose x bar is 2.17. That'll get us close enough. Okay, so if we do that, now this is going to be 2.17 instead, and that'll be 2.17 there. And if I figure that out, I'm going to get something that's a little bit more reasonable. 2.17. Yeah. Oh, wait a minute. I did a calculator mistake. You can't see it, but I can. There we go. That's better. Okay. What I end up with here is my probability that tail area is 0.1444. Since it's a two-tail test, I want to also double it because I need to add the side of being more extreme on the other side. So my p-value for this is going to be 0.2 times 2, 0.2888. So my p-value is 0.2888. And now, since 0.2888 is greater than 0.05, we would not have enough evidence to reject the null hypothesis. So don't get confused, okay? The problem I did here, this was the original problem. We definitely are going to reject the null hypothesis. Then I simply said, what happens if x bar is something else? And I made it closer to 2.2. What I wanted to show you there was when you actually have a value for a p-value, since this one ended up being 0. So there you go. Another hypothesis test. We're going to do a lot more of these before the year's